Right, so there will be your quiz, and you have to submit this one tonight. File name first. Your section S1 quiz 1A, your student ID .pdf, right? So this is the file name that you're going to use. You can use is a handwriting solution, whatever, right? So these are handwriting solutions, or you can type. There is no problem. And then due date is 12 a.m. tonight, right? So tonight you have to send it directly to me, right? Send by WhatsApp. Right, so I just add some more velocity here. I just say that the velocity is meter per second, right? So there is additional information that you can calculate the volume, the time rate of volume flow. Yes, Muhammad.
Sir,
Yes.
I just want to ask about the time rate of volume flow. Is it the formula is equal to V times area, fluid velocity times area?
Yes. You can have a different equation if you don't want to use density times areas, so you can have directly the uh, volume divided by time, right? So we have a volume, and then you have divide by time. This is also possible to get the uh, um, the volume, the density rho times the volume. So there is another equation that you can use to calculate the volume flow rate. Yep, write the equation. Just ignore that. Uh, right, so if you don't want to use that equation, I can remove that thing, right? So we have two equations. They produce the same results, right? So if you know the time rate of volume flow, you just multiply with the local densities. These are average density actually. Ya Lokman, apa dia Lokman? Daripada tadi angkat tangan tapi cakap pun tidak. Apa dia? Right, Muhammad Afiq, faham Muhammad Afiq? Okay.
Okay, okay.
Good.
Cuma soalan ni mass flow rate untuk air kan, sebab dia punya media dekat dark, so dark kalau yang saya explain tadi pasal air kan, gas phase.
Yeah. So dalam gas phase kadang-kadang diberi, right? Sometimes it's given. In this case, I don't give the value of density. So what you need to do is you have to use your own phone, right? So from the phone you can get the temperature of the air, right? And then you have to know what is the pressure at the sea level. Apa pressure kat sea level? Pressure kat sea level berapa? Pandai, pandai. Guna internet. Pandai. Bagus, bagus.
Atmospheric pressure ke Ustaz?
Pandai. Pressure dekat the sea level. Right. PATM. Pressure at sea levels. Ya, saya tulis dulu. 1 ATM. 1 ATM berapa unit? 1 ATM berapa unit?
101,325 Pascal.
Pandai, 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 pandai. Sekejap. Right. Okay, good. So you partly dah boleh answer the question. Right. So the P pressure at sea level is 1 atm. Just ignore this thing. So this is during my copy paste. So we have a pressure at sea level equal to 1 atm 101,325. Is it absolute or gauge? No, the next question that you have to ask is the pressure is absolute or gauge pressure. Absolute ke gauge ni? Gauge pressure. Afiq, kawan-kawan lain semua tak nak tolong awak pun, nampak? Seorang pun tak nak tolong. So is the pressure is absolute or gauge? Mana yang lain-lain ni, grup ni punyalah ramai sampai 40 orang. Seorang pun tak boleh nak jawab. Ni siapa ni? Segan tulis. Absolute sir, pandai Afiq. Absolute, this is absolute value. So when you have these absolute values, then you can use this information to calculate apa dia ni, Amirul. Amirul, apa Amirul? Amirul lah. Mana Amirul ni? Ada apa Amirul? Cerita cepat. Amirul tak cerita. So absolute pressure. So when we have absolute pressure, then you can using it to calculate the density. So what is the equation? Equation of state untuk perfect gas. Apa dia? Seorang. Apa equation dia? Equation untuk ni. So this is the equation that you're going to use to obtain the density, local density of air inside the pipe, right? So this is a local velocity, so local density. So if we have this domain, so we are looking at these values. Let's say, let me the position here, right? So I just copy this, the whole domain there, copy b. Oh, yep, right. So this equation actually, let me check this one. Oh, right, the whole equation here, you can using it to calculate the density at that particular location, right? um, right, these are properties. So whenever people you talk to your friends, right, I want to, and you explaining the density as a concept, then you produce these values, this equation, and then dia cakap kat you, engkau tak faham konsep, kan? I think most of your friend like to say like that. You don't understand the concept. So density is a concept, pressure is a concept, gas constant is concept, temperature is concept. So these are the way that you explain those things. Sometimes people say they want to explain to you about concept, but they don't know what concept is. Right, so this property are concept. So from the first year until you final year, you only calculate this property, right? So these are the basic property that you should know, and this property have been covered in the earlier course like thermodynamics, right? So what about a gauge pressure? When you can use gauge pressure, right? So let's say the fluid is moving, right? So the fluid is moving. So if we have atmospheric pressure at this location, right? So let's say we have now let's say that we have this, the outlet pressure is P at sea levels, right? So this is the outlet pressure. We have a pipe, and then this fluid is moved toward the exit, and the exit is far away from it is a P pressure at sea level, which is absolute. So if the pressure here is quite high, the sea level pressure is very high, the fluid will enter the pipe, right? It going to the left. But when the pressure here is higher than the sea level pressure, the fluid will be moving outside. Uh, so we have the pressure at this location must be higher than the sea level. So the differences between the pressure at this location and the sea level values, we have what we call a static pressure. Alright, so we have static pressure. And this one will be P S. Static pressure, let me write using this software PS, and the unit is cm.